In this video, we want to look at ratios and proportions. And you can look down here. A ratio is a multiplicative comparison of two quantities. And a proportion is a statement that two ratios or rates are equivalent to one another. So we have a situation here where we're wanting to make concrete, and the concrete is made up of the sand and cement. And so if we look at the number of pails of cement and the number of pails of sand in this mixture, we can see a relationship by the 3 and the 6 is, remember this is a multiplicative relationship, and 7 and 14 is also a multiplication of 2. If we want to extend this out, we see that going from 3 to 15 is a multiplication of 5, and that same multiplication is done from the 7 to the 35 is that multiplication of 5. So using this information, we want to know how much is planned to use, Bill needs if we have 18 pails of cement. So if we know that there's 3 pails to begin with of the sand, or I'm sorry, of the cement, and that is in the same ratio as the 7 pails of sand, and we want to find out what those 18 pails of cement are going to, he wants to know how much sand he's going to need for those 18 pails of cement, so the 18 pails. So it's the same thing as what you were doing in terms of equivalent fractions. This is now using some units. And so when we want to make sure we keep our labels so we know exactly what's going on here. And so we're going to look at how did we go from 3 to the 18? Well, we multiplied, remember that multiplicative relationship, and we're going to multiply by 6. And if we multiply the cement, the quantity of 3 pails of cement by 6, we need to multiply the amount of pails of sand by 6. And so we're going to end up with 42 pails of sand that will complement our 18 pails of cement, and together we would have 60 pails that will make up the concrete. I'm supposed to say sand, not same. There we go. This time we know that we have 56 pails of sand, and we want to know how much cement is going to be needed to complement our pails of sand. So we still have our 3 and 7 cement and sand, and if we look at 7 pails and 56 pails of sand, we know that we're going to multiply this by 8. And when we multiply that by 8, you will be able to find out how many pails of cement we need, and that's going to be 24 pails of cement. So let's talk about this idea of a ratio. So a ratio is also the same thing as what we were talking about here in terms of our kind of our fraction or our rate. And so now just changing the kind of the wording, we have cement to sand ratio, so that would mean we have a 3 to 7 or 3 pails and 7 pails. In terms of what we want to look at here is what is the ratio of sand to concrete. So now concrete, if you recall, is the entire mixture. So our sand amount is 7, but our concrete is the makeup of the 3 pails of cement and the 7 pails of sand. So really what we're talking about is a 7 to 10 ratio. And if we wanted to know what the percentage of concrete to sand is 7 out of those 10, which comprise the entire thing. So it's a 70% ratio of concrete is the sand. In this part of the problem, this is on page 2 now, we're looking at a recipe that calls for 1 liter of soda, and then it also calls for 3 liters of juice for a combination to make the punch. So in this question here, we want to find the ratio of the amount of soda to the amount of punch. So again, we're talking about the amount of soda, and punch is the entire thing, and that's the entire recipe, so that would be this piece. And so we know that we have the amount of soda is 1 liter, and that ratio to the amount of punch would be the combination, so that would be a 1:4 ratio. And then if we look at the bottom one here, how many liters of soda will Amy need if she wants to make 40 liters of punch? So if we know we need 1 liter of soda, and we need 4 liters to make 4 liters of punch, then we're going to look at that relationship and want to know when we get to 40 liters of punch. And so we're going to find out what that multiplier is going from here to here. And you guys can see that it's a multiple of 10. And so we can find out what goes in that spot right there. So in this last page, we want to look at Mary and her mother. And this year, Mary will be turning 5 at the same time her mother will be turning 40. And so we see that represented in this table. Then when Mary is 7, we can see that her mother would be 42. And maybe at 15, we can see that Mom is going to be 50. And at 35, Mom would be 70. And so you can fill in the other ones to help you with this answering the rest of these questions. But if we just look at, let's say, A and B here, what will the ratio of Mary's age to Mother's age be this year? Well, this year it's a 5:40 ratio. And we could simplify this to say it's a 1:8 year ratio if we are looking at how we can simplify these. If we divide by 5 in both of these cases, we get a 1:8 ratio. And then what would be the ratio of Mary's age to her mother's age at their birthday 10 years from now? So 10 years later, Mary's going to be 15, her mother will be 50. So we have a 15:50 age ratio. And then we can simplify that just because both of these numbers are divisible by 5, and so we could write it in a more simplistic form. So you can use this chart to continue to finish out the rest of these couple of problems.